Okay, now sensitization in the aplesia. All right, so this is gonna sound similar to habituation, and so I need to explain it. In habituation, you're talking about a gentle touch to the siphon. And what happens is the gill will constrict, but it becomes shorter and shorter and shorter each repetition. Sensitization is going to sound similar, but there's a key difference. In sensitization, there's an aversive shock. They will electrically shock, and it will feel it. And when you do this, the shock to the tail. But what they find is that if you do this to the tail and then touch the siphon, the next touch to the siphon, there's going to be a much longer withdrawal duration. It seems to be that when you activate the tail, and I'm going to use psychological terms to explain this, but when you shock the tail, the aplesia is kind of keyed up on its guard, worried what's going to happen. And then you touch the siphon, and when it feels that touch, it just freaks out, and it quickly constricts and is very slow to relax. So again, it's been sensitized. Now, just like habituation, you can do this for a single episode, and you shock that tail once, and then touch it, and it's going to constrict a lot. And then you touch it again, it's going to constrict, but not so long, and constrict. If you touch it again, touch it again, touch it again, this sensitization, it will recover quickly. But just like habituation, if you did this every day, it's going to become more long-lasting with multiple sessions. So if you do it for 2 weeks, shock the tail, then touch the siphon, and day 1. Day 2, shock the tail, touch the siphon, shock the tail, touch the siphon. It actually learns to have a severe response for a long period of time. Okay, so how does this happen? How does short-term sensitization occur? And how does long-term sensitization occur? All right, okay, so again, we have our graph here. We've got the siphon, the sensory neuron, but this time we're bringing in the tail. So we're bringing in the tail and saying, okay, the tail has its own sensory neuron. I'll explain this, the inner neuron, in a second, and it's all connected to the sensory neuron, which is connected to the gill muscles. Okay, so if you shock the tail, it activates inner neurons that release serotonin. So if you shock the tail, the sensory neuron will activate interneurons, and the interneurons activate or release serotonin. The serotonin, what does it do, right? It was glutamate that caused should say motor neuron right here. It was the glutamate that caused the motor neuron to fire, to constrict, and that led to the constriction of the gill muscles. But the serotonin modulates the sensory neurons, so that when these sensory neurons fire, they actually release more transmitters on the next activation. So in the short term, you have the serotonin. So in the short term, you have the tail shock and the inner neurons releasing these serotonin, and that makes, if you touch anywhere, the siphon, the tail, the mantle, it doesn't matter, the aplesia will be more sensitive, more reactive to it, because the serotonin that's what it does. Okay, so that's the short-term sensitization. In long-term sensitization, well, in long-term habituation, you have synapses that are pruned away. In long-term sensitization, again, you shock that aplesia every day for 14 days straight. It actually will create new synapses between these sensory neurons, and this, again, this should say motor neuron. It says sensory neuron, but it's a motor neuron. So the connection here is stronger. Here is stronger. Here is stronger. And what that does is it makes it more reactive when any of these fire. Okay, so that is how the brain changes with habituation and sensitization.